Breakthrough discovery. A massive glowing hydrogen cloud found near our solar system. Scientists have uncovered a colossal, previously hidden hydrogen cloud named Eos just 300 light-years from Earth, the closest such discovery ever. Detected by its faint ultraviolet glow, Eos offers an unprecedented opportunity to study how stars are born. The team, led by Rutgers researchers, used an innovative technique that may transform our understanding of cosmic structures. This ancient hydrogen has traveled for 13.6 billion years, and its discovery opens the door to even more breathtaking finds, from the nearest to the most distant reaches of the galaxy. Discovery of a massive star-forming cloud. A team of international scientists, led by an astrophysicist from Rutgers University, New Brunswick, has discovered a giant star-forming cloud, one of the largest structures ever observed in the sky and among the closest to Earth and the Sun. This massive cloud, made primarily of hydrogen, had remained hidden until researchers searched specifically for its main ingredient, molecular hydrogen. It is the first time a molecular cloud has been detected through light emitted in the far ultraviolet part of the electromagnetic spectrum, opening new possibilities for exploring the universe in this way. The scientists named the cloud Eos, after the Greek goddess of mythology who is the personification of dawn. Their findings are detailed in a study published today, April 28, in Nature Astronomy. Scientists have discovered a potentially star-forming cloud and called it Eos. It is one of the largest single structures in the sky and among the closest to the Sun and Earth ever to be detected. Credit: Thomas Muller, HDA/MPIA, and Thavisha Dharmawardena, NYU. A new window into the molecular universe. This opens up new possibilities for studying the molecular universe, said Blakesley Burkhart, an associate professor in the Department of Physics and Astronomy in the Rutgers School of Arts and Sciences, who led the team and is an author on the study. Burkhart is also a research scientist at the Center for Computational Astrophysics at the Flatiron Institute in New York. Molecular clouds are composed of gas and dust, with the most common molecule being hydrogen, the fundamental building block of stars and planets and essential for life. They also contain other molecules, such as carbon monoxide. Molecular clouds are often detected using conventional methods such as radio and infrared observations that easily pick up the chemical signature for carbon monoxide. Breaking through with far ultraviolet detection. For this work, the scientists employed a different approach. This is the first ever molecular cloud discovered by looking for far ultraviolet emission of molecular hydrogen directly, Burkhart said. The data showed glowing hydrogen molecules detected via fluorescence in the far ultraviolet. This cloud is literally glowing in the dark. Eos poses no danger to Earth and the solar system. Because of its proximity, the gas cloud presents a unique opportunity to study the properties of a structure within the interstellar medium, scientists said. The interstellar medium, cradle of stars. The interstellar medium, made of gas and dust that fills the space between stars within a galaxy, serves as raw material for new star formation. When we look through our telescopes, we catch whole solar systems in the act of forming, but we don't know in detail how that happens, Burkhart said. Our discovery of Eos is exciting because we can now directly measure how molecular clouds are forming and dissociating, and how a galaxy begins to transform interstellar gas and dust into stars and planets. Eos's enormous size and fleeting existence. The crescent-shaped gas cloud is located about 300 light-years away from Earth. It sits on the edge of the local bubble, a large gas-filled cavity in space that encompasses the solar system. Scientists estimate that Eos is vast in projection on the sky, measuring about 40 moons across the sky, with a mass about 3,400 times that of the Sun. The team used models to show it is expected to evaporate in 6 million years. The use of the far ultraviolet fluorescence emission technique could rewrite our understanding of the interstellar medium, uncovering hidden clouds across the galaxy and even out to the furthest detectable limits of cosmic dawn, said Thavisha Dharmawardena, a NASA Hubble Fellow at New York University and a shared first author of the study. Hidden in plain sight, how Eos was found. Eos was revealed to the team in data collected by a far ultraviolet spectrograph called FINS-SPR. an acronym for fluorescent imaging spectrograph, that operated as an instrument on the Korean satellite STS-81. A far ultraviolet spectrograph breaks down far ultraviolet light emitted by a material into its component wavelengths, just as a prism does with visible light, creating a spectrum that scientists can analyze. The data had just been released publicly in 2023 when Burkhardt came across it. It was kind of like just waiting to be explored, she said. Why EOs eluded detection for so long? The findings highlight the importance of innovative observational techniques in advancing the understanding of the cosmos, Burkhardt said. She noted that EOs is dominated by molecular hydrogen gas, but is mostly TO dark, meaning it doesn't contain much of the material and doesn't emit the characteristic signature detected by conventional approaches. That explains how EOs eluded being identified for so long, researchers said. The story of the cosmos is a story of the rearrangement of atoms over billions of years, Burkhardt said. The hydrogen that is currently in the EOs cloud existed at the time of the Big Bang and eventually fell onto our galaxy and coalesced nearby the Sun. So, it's been a long journey of 13.6 billion years for these hydrogen atoms. A surprising twist in cosmic research. The discovery presented itself as something of a surprise. When I was in graduate school, we were told that you can't easily directly observe molecular hydrogen, said Damour Dana of NYU. It's kind of wild that we can see this cloud in data that we didn't think we would see. EOS is also named after a proposed NASA space mission that Burkhardt and other members of the team are supporting. The mission aims to broaden the approach of detecting molecular hydrogen to greater swaths of the galaxy, investigating the origins of stars by studying the evolution of molecular clouds. Searching for molecular hydrogen across the universe. The team is scouring data for molecular hydrogen clouds near and far. A study published as a preprint on ArXiv by Burkhardt and others using the James Webb Space Telescope, JWST, reports tentatively finding the most distant molecular gas yet. Using JWST, we may have found the very furthest hydrogen molecules from the Sun, Burkhardt said. So we have found both some of the closest and farthest using far ultraviolet emission. Reference: a nearby dark molecular cloud in the local bubble revealed via H2 fluorescence, 28 April 2025, Nature Astronomy. DOI 10.4155025-02541-541-7. Other members of the scientific team included researchers from Technion Israel Institute of Technology, Haifa, Israel, Queen Mary University of London and University College London, both of London, University of Iowa, Iowa City, Iowa, Korea Astronomy and Space Science Institute, University of Science and Technology, and Korea Advanced Institute of Science and Technology, all of Daejeon, South Korea, Max Planck Institute for Astronomy, Heidelberg, Germany, University of Texas at Austin, Austin, Texas, University of Arizona, Tucson, Ariz, University of California, Berkeley, Université Paris Sidi, Gif-Vat, France, Space Telescope Science Institute, and Johns Hopkins University, Baltimore, University of British Columbia, Vancouver, Canada, Columbia University, New York, and the Harvard-Smithsonian Center for Astrophysics, Cambridge, Mass.